Moving on to the next questions in the electrical circuits. For a sine wave, amplitude factor is, okay, see the option A is 0.707, option B is 1.414, option C is 1.11, option D is 1.21. So amplitude factor is the ratio of first order deflection to second order deflection, and its value is root 2. Okay, amplitude factor's value is root 2. So root 2's value is 1.414. So for a sine wave, the amplitude factor is root 2. Okay, so root 2 means 1.414, and option B is the right answer. Next question, question number 94. I had left this question. Question number 94. A circuit whose characteristics change in the direction of current or voltage is called dash. Okay, option number A bilateral, option B unilateral, option C linear, option D non-linear. Okay, a circuit whose characteristics change with a change of direction of current or voltage are called as bilateral. Okay, option A is the right answer. Okay, question number 98. The power dissipated in the circuit resistance is, first option reactive power, second option apparent power, third option volt ampere power, fourth option active power. Okay, so we have a power triangle over here. Actually apparent power is equals to active power plus reactive power. Okay, so apparent power equals to P active means Vi cos phi plus P reactive Vi sin phi. So this is the Vi cos phi is the active power and Vi sin phi is the reactive power. Okay, so active power's unit is kilowatt or watt simply, and reactive power's unit is kVAR or simply VAR, volt ampere reactive. But what has he asked? The power dissipated in the circuit resistance is volt ampere power. Answer is C, volt ampere power. See, in the resistance, so suppose this is the resistance and this is the source of AC, current flows here. So voltage and current, this is voltage and current will be in phase. So there will be no phase angle between the voltage and current. So there will be no power factor. Power factor is, there will be a power factor. The power factor is unity, cos phi equals to 1 because there will be no phase angle between voltage and current, right? So cos 0 is 1. Hence we know the power equation P equals to Vi cos phi and V into I. Cos phi value is 1. So power dissipated in the resistor is simply volt amps. Voltage unit is volt and current's unit is ampere. So the power dissipated in the circuit resistance is simply volt ampere power. Now let us solve the questions on electrical circuit. Subject is electrical circuit for the same paper Dcet 2019 for electrical branch. So question number 99 says that the EMF induced due to relative motion between the flux and the conductor is called as dash. See the options. First one statically induced Dmf, second option dynamically induced Dmf, C self-induced EMF, D mutually induced EMF. Okay, these are the options. The EMF induced due to the relative motion between the flux and the conductor is called as dynamically induced EMF. Okay, consider this coil. This coil is, you can say it as solenoid, and this is the magnet. So flux will be like this. Flux will be produced like this. Flux will be like this around the magnet. Okay. So if an EMF induced in this coil, due to the relative motion between these two. See, suppose magnetic field or the magnet is constant and the coil is moving relatively, then also EMF is induced. If the coil is constant or stationary and the magnet is moving inside, means moving and coming outside, inside and outside means, then also flux changes. So in order to generate EMF in this coil, there should be a relative motion in between these two. Okay. So if there is a relative motion in between them and EMF induced in the coil, then it is called as dynamically induced EMF. Coming to statically induced EMF, the EMF induced in the coil when it is stationary, then it is called as statically induced EMF. Okay. Self-induced EMF, you will find it in transformer. Okay. See, here the coil is there, here also one coil is there. We will give supply over here, so V1, an EMF induced here, and after this flux passes through the core and another EMF is induced here, and we will get terminal voltage over here. See, this is the primary and this is the secondary. In the transformer primary side, we will give the supply. Due to the change in current, flux is changed. Due to that change in flux, EMF is induced. Okay, statically. So statically induced EMF also, and it is also called as self-induced EMF, because self-induced EMF means the EMF produced in one coil due to the change in flux in itself, then it is called as self-induced EMF. So self-induced EMF means this. Then another option is there, mutually induced EMF. Okay, mutually induced EMF means an EMF induced in one coil due to change in flux in another coil. See, we are giving supply over here, current is changing, alternating supply will give, current changes alternatingly, flux also changes, then one EMF is produced, E1, that is called as self-induced EMF. Due to change in flux in here, another EMF E2 is induced in the secondary. This EMF is called as mutually induced EMF. Okay, mutually induced EMF means an EMF induced in one coil due to change in flux in another coil. It is called as mutually induced EMF. Self-induced EMF, nothing but an EMF induced in one coil due to the change in flux in the same coil, then it is called as self-induced EMF. Stationary induced EMF means an EMF induced in a coil when the coils are stationary, flux is changing, then it is called as statically induced EMF. So, but our question is, the EMF induced due to the relative motion between the flux and the conductor is called as dynamically induced EMF. Okay, option B is the right answer. Moving on to the next question, question number 96. Unit of magnetic permeability is dash. Okay, see the options. Option A, Weber per meter square. Option B, Weber per ampere turn. Option C, Henry per meter. Option D, Tesla. Weber per meter square is the unit of what? Magnetic flux density. So B equals to flux per unit area. Flux's unit is Weber and area's unit is meter square, and it is also called as Tesla. Okay, option D and option A are the units of magnetic flux density or magnetic field. Coming here, option B, Weber per ampere turn. There is no unit like that. We have ampere turn per Weber, right? Ampere turn per Ni by 5. This is the ampere turn per Weber is the unit of reluctance. Okay, reluctance. So reluctance's unit is ampere turn per Weber, but Weber per ampere turn is not the unit. But option C, Henry per meter, is the unit of magnetic permeability. Okay. So magnetic permeability means ability of a material to support the production of magnetic field in it. So that is called as magnetic permeability, and its unit is Henry per meter. So option C, Henry per meter, is the right answer.